Hi, this is Gary Lerude of Microwave Journal. Today, I am pleased to be talking with Mike Roberg, a fellow at Qorvo who is working in the field of MMIC power amplifier design. Mike has designed several of Qorvo's commercial GaN PA MMICs, and in recognition of his work, the Microwave Theory and Technique Society of IEEE has selected him to receive the Outstanding Young Engineer Award for this year. Mike, congratulations, and thank you for talking with me.
Absolutely. Thanks for having me, Gary.
According to the MTT, the Outstanding Young Engineer Award was developed to recognize accomplishments early in a career. Describe your work that this award is recognizing.
Sure. So I'm a fellow of MMIC Design Engineering at Qorvo, and I mainly deal with designing MMICs and 3.5 technologies, such as power amplifiers, switches, things of that nature. And so this is basically a halfway point career award that's recognized a lot of the designs which I've done, which are for both commercial and government customers, as well as some of the analysis techniques I've developed. So some of the designs, for example, would be like the TGA 2962 and QPA 2966D, which are 2 to 20 gigahertz decade bandwidth power amplifiers that I've recently released. My very first design was actually the TGA 2578, which is a 2 to 6 gigahertz 30 watt power amplifier. And some other ones I've been recently working on are some of the wide video bandwidth communication system amplifiers, such as the TGA 2239, the QPA 2212, things like that. So really, it was a great award to receive. I'm very humbled by it for all the outstanding MMICs that basically I've designed in the last 8 years of my career at Qorvo.
Sounds like an impressive list. So if we go back to the beginning, what led you to choose engineering as a career?
Sure. So ever since I was a little kid, I was very interested in electricity. I just thought it was almost magic when I was a little kid. I think there's a quote somewhere that says, any sufficient technology that's beyond what people know is viewed as magic. But I always wanted to take things apart when I was a kid. I think what sealed the deal for me is when I was in 6th grade, I built an electric motor for my science fair project. And then I won the science fair, and I sold that project to my teacher for $20. So I think that gave me the spirit of wanting to be an engineer in a commercial type industry and be able to make things and sell them to people. That was just something that was always really interesting to me.
Yeah, a bit of an entrepreneur bug there too.
Yes, yes.
So what universities did you attend?
So after I graduated high school, I had an amazing opportunity to attend a university called Bucknell University. I imagine a lot of people aren't familiar with that outside of maybe some of their big wins in the NCAA basketball tournament. But it's a very nice university in Pennsylvania, and I was given basically a scholarship called the Kenneth Langone Scholarship, which allowed me to attend that university, and that's kind of where I developed my my love for microwave engineering through one of my advisors at that university, Dr. David Kelly. He really is the one that kind of interested me in that field. I didn't know anything about it at the time, and so I do owe a lot to him in terms of moving forward in my career in microwave engineering.
And it sounds like you went to work after that at Lockheed and maybe got your master's while you were working at Lockheed?
Correct. Yes. When I graduated Bucknell, I had a great job opportunity with Lockheed Martin in Moorestown, New Jersey, with their engineering leadership development program. And through that program, it was required to get a technical master's degree. And so I chose to attend University of Pennsylvania, just right across the river. And I got my master's degree in electrical engineering at that time.
And then you went back to school to get a PhD and then joined Qorvo. What led you to choose Qorvo?
Right. So yeah, I left Lockheed Martin, went back and got my PhD at University of Colorado. And what really led me to Qorvo, which was actually Triquin at the time, as you know, was I attended Anaheim, IMS at Anaheim in 2010. And I was competing in the student design competition for power amplifiers at that time. And through that, I met Chuck Campbell, who everybody knows in our industry pretty much, and also Eli Reese and some other people from Triquint. And they really convinced me, that Qorvo was a great company, and that stay in touch with them. I was early in my PhD at that time, so I was a job wasn't on the horizon for a few years. And Chuck Campbell came up a few times to the University of Colorado and just kind of blew our minds with things that we were allowed to do in MMIC processes. We just didn't think that they would allow us to do those things, and so really just showed us the amazingness of the creativity that you could inject into an engineering career. And when it was finally time to get a job, I talked to Chuck, and he's like, "Hey, this is a great company to work for. It's all up to you. If you're not going to be held back by anything but you, and you can really move forward and do great things at this company and be very creative and solve technical problems." And that was super attractive to me. I wanted to kind of control my own destiny from a career standpoint, and Qorvo really allowed me to do that.
And what was the focus of your PhD work?
The focus of my PhD work was basically high efficiency nonlinear transmitters. So I did a lot of work in high efficiency power amplifier design under Dr. Zoya Popovich, University of Colorado, a great advisor. She really allowed me to just kind of do my own thing and just provided help and funding and things when I needed them versus trying to really control exactly what I was doing. And I really enjoyed that. And I owed her a great debt of gratitude for giving me the opportunity to be a part of her group. I hadn't done any microwave engineering prior to coming to her group. I was mainly a radar systems design engineer, doing things like digital signal processing and algorithms. So I had a lot of the context of the things that I wanted to be able to do in microwave engineering. I just didn't know a whole lot about microwave engineering itself. So I really owe her a lot for allowing me that opportunity.
Well, it sounds like you've done a lot of design work at Qorvo. Talk some more about the interesting work that you're doing there.
Sure. Recently, what I've been working on are two main things, and they're two large drives within the industry. Decade bandwidth power amplifiers. So the 2 to 20 gigahertz band is a super interesting band to be playing in for all sorts of reasons. And so I've been doing a lot of research and design in trying to realize higher efficiency, higher performance decade bandwidth power amplifiers. And that research has kind of culminated into two of the recently released commercial products, which we have, which are the TGA 2962, which is the 10 watt 2 to 20 we offer, and the QPA 2966D, which is the 20 watt 2 to 20 gigahertz power amplifier we offer. The other things that I've been working in are the communication systems amplifiers, specifically the Ka band at this moment, for very wide video bandwidth. Customers are really starting to push the envelope with the video bandwidth that they want to have out of these power amplifiers. And so that presents some interesting design challenges beyond just trying to achieve power and efficiency, which is kind of the legacy way people have approached power amplifiers. And so I would say at this moment, those are the two main things I'm working on. Some of the 5G stuff is starting to get interesting and things related to 5G, but mainly the stuff that I've already mentioned is what I've been working on.
So I recall the early days of MMIC design, models were essentially non-existent, and the correlation between actual device parameters and microwave performance was largely unknown. Where would you say the frontier of MMIC design is today? What are the real challenges?
Sure. So we're getting a lot better there with the models in both the active device models and the passive modeling. We're certainly able to do a lot better correlation to measured performance relative to simulated performance than we were 10 years ago. I think honestly, we're going through a bit of a renaissance right now with the size of the electromagnetic problems we're able to simulate based upon the computing power that we have available at our fingertips these days. And the software vendors are really trying to harness that to do things like parallel processing. It's very impressive. And so that allows us to solve problems that 20 years ago or even 10 years ago, you wouldn't even have tried to solve. You can solve 1,000 port simulation right now with some of the large computing power that we have at our fingertips at Qorvo. And so that really allows you to get that extra performance out of a design and make more challenging designs. The other thing I think that we're going to experience even more of a renaissance with is the nonlinear device modeling. That has improved substantially in the last 10 years that I've been at Qorvo, and I see that being something that gets even better and better as we move forward, particularly from the standpoint of solving some of the GAN trapping modeling issues that we have, as well as some of the linearity challenges that we have with some of our nonlinear model frameworks. And so I think we're going to see a lot of changes in that, which is going to lead to improved MMIC designs and systems in the future.
Seeing some of the direct benefits of Moore's law with the increase in processing power, definitely.
Absolutely.
So turning maybe more personally, what wisdom have you learned in your career so far that you would offer to others in the industry?
Sure. I guess I have several great pieces of advice, I think. This is a tough competitive industry. You're going to have failures. It's inevitable. And so the thing to remember, I think, with that is that it's only a failure if you do the same thing again and have another failure. You have to learn from those failures. And so just make sure you learn from your mistakes and don't make them again. Another piece of advice would be understand the prior art and the state of the art. Really make sure you have a good base on what has happened before you. And what you really want to do is you want to question those things that have been done before you. Why have they been done? How can they be done better? Because a lot of people will try to tell you things are impossible. And really, it's the people that go solve the impossible problems that move things forward. And so don't ever just assume something's impossible because somebody hasn't done it. That's the easy way out. You just got to keep pushing that envelope. Never stop improving, never become complacent. That's, when you become complacent as an individual or a company is when somebody surpasses you and then you're playing catch up, and you never want to be in that mode. So you always want to try to be getting faster and better at what you do from both either a company standpoint or a personal standpoint. It's a lot easier to stay ahead than it is to play catch up, as we all know. And I guess my final piece of advice would be for anybody that's not even a chip designer, but considering doing it is, it's really a monumentally rewarding experience to design microchips and see them turn on and work and go into systems. And, I've been doing this for, obviously not as long as a lot of other people, but almost 10 years now. And that feeling never gets old. When you see that power amplifier turn on and work and not oscillate, it's always a great feeling. And so, it's a very rewarding job, and I would encourage anybody that's interested in kind of meshing an engineering career with a creative artistic career. Chip design is a great place to go if you're interested in those things.
So I guess I'll have to ask you, how many power amplifiers have you blown up when you first turned them on?
Ooh, first turned them on?
Or
Yeah,
at
a
any
few.
time?
Oh, a lot, Gary. Come on. Yeah, I've blown up a lot. Obviously, amplifiers are better known as just unruly oscillators that you've convinced to behave. And so, sometimes you don't get the bypassing right the first time, and you turn it on and it fries, or didn't get the die attach right, or it fries. There's all sorts of things that can go wrong. But when you get it right, you get it right. And so I mean, especially at Qorvo, we go through very, very rigorous testing to make sure we don't blow them up. And through that process, a lot of times we find ways to blow them up, and then we fix that, because we'd rather blow them up ourselves than send them out to customers and blow them up. So
Very true.
yeah.
Well, Mike, I've enjoyed our conversation and appreciate you spending some time with Microwave Journal. And congratulations on the Outstanding Young Engineer Award. It sounds like it's very well deserved.
Thank you very much, Gary. It was really great to talk to you. I really enjoyed this.